Hi all, welcome to Arohi Tech in Hadoop series. Today's lecture will discuss about what is metadata and what is daemon and how the checkpointing is happen exactly in the backend or internally how it is happening. We'll discuss. Okay, so what is daemon in Hadoop? There are some daemons are running. Okay, so what is daemon? Daemon is nothing but an ever running background process. So if in Windows machine, if you go to the task manager, you can have many processor running. This is called process or okay, this process Google Chrome is running, Microsoft is running, Teams is running, and many more programs you can have a look as well. Okay, so these are the process running in the backend in the Windows machine. The same thing in Linux machine also. If there is a service, the background in the backend, some process will be running related to that service. Okay, so in my name node, in our name node, what will happen? The name node daemon or name node service should be running in this master machine. That's why we can set it a name node. If the name node is not running, the this daemon or this process is not running in the master machine, then it cannot function. The name nodes functionality cannot happen. Okay, it cannot manage or it cannot contact to the data nodes. That's why the name nodes should have running forever. Then only it can control the entire cluster or it can do its functionality. The same thing, the data node or the worker machine or the slave node, all the terms are same, but we can set it a particularly we can set it a data node because the data node daemon is running in this machine, in the slave machine. That's why we can set it a data node. And this one also, data node daemon should running in the background. Okay, here also in all the nodes, all the slave machine, the data node daemon should be running. Then only it can accept the blocks which is guided by the master machine to the client. So if any data is going to be distributed across the data nodes, if the data node daemon is not running, it cannot accept the data. Okay, that's why it have to have run the data node daemon. So that is called all the daemons. So any specific service is there, then that particular service should be, or that particular process or the daemon should be running in the background forever. Then only it can do the functionality of that particular component. Now coming to metadata. What is metadata? Already we have discussed about the metadata, but what is metadata? The data about data or the information about the data. But here very particularly how to define the metadata exactly. So here just I'm quickly narrating all those things. The file A 100 MB, it is divided into two blocks, B0 and B1. B0 is 64 MB and B1 is 36 MB. Both to combine, we can have 100 MB file A. So B1 is going to data node 1, okay, and B0 is going to data node 1, and B1 is going to data node 3. And due to the replication factor 3, the by default replication factor 3, it has 3 copies. So anyhow, it will be distributed data node 2, the both the copies, and data node 4 as well. So what is the point here? The replication factor, due to the replication factor 3, that's why I can have the 3 copies the in this Hadoop cluster. Okay, now the master machine having all the information. Okay, so now the file A is there, it is divided in two blocks. Blocks are distributed across different data nodes, and due to replication factor, it can have 3 copies because the default replication factor is 3. So that way it has been distributed. Now we have to define the metadata. So what is metadata? Metadata is nothing but the data about data or the information about the data. So exactly what is there? Okay, so here we can say file A. The first point is file name, then file size, number of blocks, block size, location, replication factor, file permission, and so on, and so many more internal things as well. But this is the high level overview of the metadata. So for example, here what is the notations? File name. File name is file A. Okay, and file size, it is 100 MB. Okay, how many blocks? What is number of blocks? 2 blocks. And what is the default block size? The 64 MB is the default block size for the Hadoop WonderText. That's a 64 MB. Okay, and a number of block and location. What is the location? Exact location. The B0 having data node 1, data node 2, and data node 4. Okay, so the same thing. The D1. Okay, D1 means data node 1 having B0, data node 2 having B0, data node 4 having B0. Same way in data node 2, B1 is there, and data node 3, B1 is there, and data node 4, B1 is there. So like this is the location of the blocks. And what is the replication factor? Replication factor is 3. And what is the username? HD user. And what is the permission? The read write executive for the owner, read and executive for the group, and read only permission for the others, and so on. And what is the date and time stamp of the file? So all includes, we can set it a metadata. And metadata stores where? It is stores in the system RAM as well as in the hard disks. Okay, so now, okay, so we'll discuss the metadata is like this. So this is the overview of the, or this is the high level overview of the metadata. But if you go, so if you go on and on, we can have some internal things attached to this metadata. And metadata stores in the system RAM as well as in the hard disks. And what consists of metadata we'll discuss later. Now coming, we have introduced only the name node and the data nodes, right, before class in our previous classes. But now today another master machine we wanted to introduce here. So data node, name node plus data node, we can set a HDFS file system. And HDFS file system deals with only the storage part of the files and folders or any data. Okay, but if coming to the job, now the storage part is okay. I am okay with the storing part by utilizing the name node as well as the data nodes. Okay, now I want to process the data. Okay, data is stored uh, across the cluster or with the multiple of data nodes. But now data is present, but now I wanted to do some analytics against the data. I wanted to apply some problem statement against this data to get some output, to get some business meaning out of my data. So for that reason, for processing the data, there is another component that is called master machine has been introduced, that is called job tracker. In Hadoop WonderText, we can set it a job tracker. This is the master machine for doing the job. Okay. For the same thing, it has the slave machines. So slave machines nothing but the task tracker. TT means task tracker. So it is running in the same data node. Okay. This is the lightweight daemon. So it should run in the same data node, that is called task tracker in this machine, task tracker in this machine, task tracker in this machine, in this machine, in this machine. Means all the data nodes having also the task tracker. So task tracker is related for the job execution. So job tracker JT, okay, job tracker is nothing but JT, that is called the master daemon for processing, and task tracker is the slave daemon for the processing. So job tracker plus task tracker, we can set is a map reduce. Okay, job tracker plus task tracker, we can set a map reduce. And how the job execution will happen, we'll discuss some other classes. But for time being, I can say job tracker plus task tracker, that is called for processing, we can set a map reduce. And name node plus data node, we can set a HDFS. So what is Hadoop then? The Hadoop is the combination of both HDFS plus MapReduce, MAP. Okay, HDFS plus MapReduce, that is called Hadoop, HADOP. Okay, so by combining HDFS plus MapReduce, we can set it a Hadoop. Okay, now going further, we can discuss about the metadata. So metadata is nothing but data by data, already we have discussed, and it resides, it stores in the memory. Why in the memory? Because for the faster access, as well as it can stores in the hard disks. Okay, so the entire metadata is in the main memory, no demanding paging of the file system. So there is no paging will happen because paging is nothing but swapping. Okay, swap space in the Linux, you can say. Okay, so what does it mean? Means if your RAM is getting full, so once it is full, the idle processes, okay, the idle process will going to the hard disk. So that is called swap area or paging file system, you can say. So it will create in the hard disk some space can be uh, allocated for the paging size in the Windows machine. If you go for the Linux, you can see it is a swap space. But no, demand paging file system should not be enabled, because if it will do, because the hard disk is very slowest component. Hard disk and RAM, the communication will happen, but hard disk can f- it can store the data, and while accessing the data it will take a longer time if you compare with the RAM, because RAM is faster access, it will be very quickly to access. So in Hadoop cluster, when you are setting up the Hadoop cluster, the paging we have to disable, or the swapping we have to disable. Otherwise you can have some performance issues in some cases. So that's why that is the thing. It will be that metadata stores in the system memory for the faster access. And type of means the what are the attributes, what are the components of the metadata, like list of files, list of blocks for each. Already we discussed all the components. Same thing here narrated. And coming to metadata, metadata consists of two files, we can say. One is fs edit and another is fs image. Edits and fs image, that we'll discuss. So what is the transaction log? That is called record of the file creation and deletion, that is called edits. And fs image is the file system uh, image. Okay, that we'll discuss. So this is the checkpointing will happen. Just a moment. Let me clarify that one. If it is there, otherwise, yeah, it is there. Let me do one thing. I'll take this slide a little bit up. Okay, yeah. So metadata is consisting of the edits and fs image. So what is edits? This is the recent transactions. What is the transaction in Hadoop? We can have the transactions. Every time we are adding some files, we are reading some files, we are writing some files, and we are deleting some files. So that process, okay, the deletion, addition, all those things we can say it is a transactions. So records will be that records we can say it is a edits. Okay, that is called edit logs or edits. And fs image is nothing but the file system image. So at the point file system image means it will take a consistency snapshot, photocopy, and it will stores. So if edits plus fs image, both we can set it a metadata. We'll discuss very thoroughly how it is exactly. Okay, and the checkpointing will happen now. Will okay, metadata is a bit clear. Okay, edits is nothing but the transactions. So for if you take the example, suppose if you go to your bank, okay, you can have your account. Suppose you have deposited 100 rupees. Okay, you have deposited 100 rupees. Again, after some days you have deposited 200 rupees. Then after some days you have withdrawn 100 rupees. So what will happen? Okay, so how much the total balance. Okay, you have deposited 100 rupees first instance. Okay, then again you have deposited uh, 200 rupees again. Okay, then again after you can withdraw the rupees 100. Okay, so what is the balance amount? What is the balance amount? Like 200, right? Exactly 200. So what will happen in the edits? I can have all the transactions. In edits, all the transactions we can have like 100 rupees, 200 rupees minus 100 rupees as well. Okay, so this is called edits. This is called edit logs. If you go through this record, same thing we can get by calculating how much the balance amount you have. But if you go to the total balance, okay, you can have that 200 rupees. So here these three records we can say it is a edits. Okay, but if you go for the fs image, this is the fs image. What is that total amount? What is the balance sheet exactly? So if suppose your balance you have lost, somehow you have lost, so can I get my metadata exactly? Yes, we can get it. We have to go through the records. record by record, one record, two record, and third record. Then I can calculate and I can have my metadata, or we can say it is my FS image. So if you have lost this one also, we can go through like, if you lost this one also, we can have the metadata as well. Okay, like FS image. So this is the importance of edits and FS image. Like this, any recent transaction will happen. Again, if something if you can add or subtract or withdrawn, then automatically it will be calculate, it will be pointing one record, it will adding the keep on adding the records, and the balance it will be immediately, it will be changing. Okay, the same way we have adding the files into the Hadoop file system, or you have deleted some of the files from the Hadoop file system, then that records will be that records, that transactions we can set to edit logs or edits. An FS image is nothing but the file system image or the photocopy of that particular point of time. Okay, in that particular point of time, what are the exact latest FS image, that is called FS image, or the photocopy means what is the exact metadata information. So both edits plus FS image we can set a metadata, and we can have a demo how we can, I can show you what is the how edit looks like, how FS image looks like, and how it is happens. Okay, how if you adding how the increasing of edit logs will be, and how FS image will be happen. We'll discuss that. And what is the checkpointing? The checkpoint will happen, you know, by scheduling, like by default like 60 minutes. The checkpoint will happen from primary node or name node to the secondary name node. The secondary name node will contact to the name node, and it will ask for the metadata after 60 minutes or 1 hour, every 1 hour. Okay, and we can have the metadata in RAM as well as in the hard disks. Okay, and here secondary name node checkpointing node, you know already, and it is not a hot standby. It is a cool backup. Every 1 hour, it will ask for the metadata uh, to the name node, and it will copy and it can stores inside the secondary name node's hard disk. Okay, and system RAM as well. Same thing already we discussed. This is a cool backup. Every 60 minutes, it can ask for the update to the master machine. So here edits will be stored in the system RAM, and it can copy to the secondary name node. And we can have multiple of data nodes. This is the diagram through which it can the second name can fetch the data from the name node. So this is one question, like when a name node fails, secondary name node takes over instantly and prevents the cluster failure. Is it? No, because it is not a hot backup. It is a cold backup. It will not take any control when the name node goes down. Okay, only it can do what, it can copy, it can store the metadata. So if in case if the metadata is corrupted in the name node, after fixing the name node issue, I can copy the data from the second name node to the name node. Otherwise, if I don't want to make it offline, or it is something corrupted, we cannot replace, we cannot do we cannot fix the issues, then I can do some configuration changes and I can make it a name node, but there is a downtime is there. Okay, so that it can communicate with the other nodes and it can function as a name node after doing the configuration changes, after making the second name node as a name node, then only it can happen. Okay, this data split and metadata already we discussed the data how it splits. Like if any data is there, according to the block size, like 64 MB in the default block size for the Hadoop 1 data X, it will divide it into number of blocks. The data can be divided into number of blocks, and that can be spread across all the data nodes. And now after it spreads, it will update its metadata by the name node. When it stores into the data nodes, the updation will happen in the metadata. Okay, all the metadata already we discussed, that is called FS image and edits. In the system memory, it will be stores for the faster access, as well as it can store in the disk. So in the disk, what it stores, the edits plus FS image, but in the memory we can have the dynamically built-in bitmap. We can say, like, you know, the transactions, recent transactions will be stores in the in the system RAM for the faster access. Now we'll discuss how exactly the checkpointing is happening. Okay, so you know already we know that what is edits and what is FS image for the metadata perspective. So both we can set it a metadata. Now in my system, in my name node machine, I can have the edits and fs image. After 1 hour of schedule of the checkpointing system by the secondary name node, so what will happen, the edits will go to the secondary name node, as well as the fs image will be going to the secondary name node. Means it will copy the data, okay, after requesting by the secondary name node in every 1 hour, it will copy, it will contact it to the name node, and it will copy the data fs edits and fs image. Now the edits and fs image is with where the secondary name node as well as the name node machine. So what will happen in the secondary name node, it will merge both of them, it will merge both of them. Why it will merging, we'll discuss. So merging will happen, and again it will form one fs image, ckpt means checkpointing. So that it can, we can say it is a checkpointing image, means edits plus fs image. This is the complete metadata, that is called fs image checkpointing, ckpt. Okay, then this image when it forms, it will copying to the primary, means it is copying to the name node machine. Why it is copying, why not it is copying here, because name node only doing the checkpointing, only it stores, it will copy the data from the name node and it will stores in the secondary name node. That's all, there is no other job by the secondary name node machine. For that reason, it has given the task to merge the data and copy the data to the primary, or you can say it's a name node machine. Now this latest data, okay, the both the complete metadata is now presented where, in the name node machine. So at this particular point of time, somebody has been added some data, okay, some data. So when it is added or deleted some data, so what will happen, this edits will rolling back, it's rolling to the edits.new. Now this edits gone. Now this edits when this edits when anybody, okay, this is already copied. So now at this particular point of time, when anybody is deleting the data or adding the data, so what will happen, this edits will become the edits.new. Okay, this is the new one. Now this is the new one. Okay, now this new one, after adding some files or adding some deleting some files, what will happen, this edit.new will become the edits. Now it will becomes the edits, and here the checkpoint will came into the picture, that the latest, the previous metadata is in this one, fs image dot checkpointing. So this one also rolling back to the fs image. Okay, so this is the newly added edits, and this one is the previous checkpointing complete metadata. So complete metadata and plus this one, that is called that both we can combine, we can say it is another checkpointing or another metadata, new metadata. Okay, this is the old metadata. Now after adding some files into the edit logs will be rolling back from the new to edits, and fs checkpointing will rolling back to the fs image. So this is the previous method, and this one is the recent transaction. So both we can say it is a, by combining both we can say it is a latest fs image or latest metadata. So this way the checkpoint will happen internally. In this diagram it is represented this way. Okay, so this is all about the internally mechanism of the checkpointing system. So this way it will be keep on changing, keep on adding the files, keep on creating the fs image. So after again, after 1 hour, what will happen, this one and this one will go to the secondary node as a copy, then again there it will combine, it will copy to the fs image just checkpointing, and this edits again, after adding some of the files it will become the edit.new, that is empty one, and after adding some files it will become rolling back to the edits, and this fs image checkpoint will become the fs image, and so on. It is the process going on, keep on going after 1 hour, because the schedule is one hour for the checkpointing. So this is all about the internal mechanism of the checkpointing system. Okay, see you in the next session. Thank you so much.